Class, good morning. Welcome to Algebra 2 on December 2nd here. Just real quick here. How about this? How about a thumbs up if Thanksgiving break was great, sideways if it was okay, and then you know what thumbs down mean. Ready? So how was Thanksgiving break? Oh, okay. Most sideways. Oh, wow. Okay. Gotcha. I'm sorry to hear that. Is it because did not get to visit, or you actually had schoolwork to do, or what? What's up with that?
Lots of work, just like actual work, not schoolwork.
I had nothing. It was amazing.
Okay. Glad someone. Okay, so cool. So attendance purposes, real quick here, as I'm looking at the screen, because I have my small screen in front of me. I assume that's Isabel on the right and Stella. Okay. Landon, Dylan, Sweet, Annette, and Carly. Okay, and then I could just, Camille, you're sitting in the back. Who's in front of you?
It's Abe and Camille.
It's what? Oh, Abe.
The front.
Abe, right, yeah. Abe, I can make out like you're just your head, but I can't see who it is. So Owen is not there then?
No.
Okay.
Yeah,
No, he's not. He said
Okay.
he's coming back on Monday.
he is.
Gotcha. Okay. I was not feeling well Monday, and then I figure I'll be better today, and I woke up feeling not so good. So hopefully I'll get there Friday. All right, class, let's go with it here. I wanted to ask you how did it go on Monday? We had the we had the fun guy presenting the lecture to you guys. Did you guys like his intro? Okay, it was the default Apple movie intro, but it was kind of cool. So you guys talk to me here. How did lecture go? Did you guys understand it? Did you guys get through both videos? One was like 18 minutes, the other one was 9 minutes.
We got through them both.
Both, okay, perfect. And the next question is, was it understandable? Made sense? All the good stuff here. Yeah, okay, it made sense. Okay, next is, I do want to kind of start, the chapter 1 actually has 10 sections inside it. So I do want to just stop. This is the halfway point of the chapter, 1.5, and we want to just take a test on half of chapter 1 since it's so long. So first things first, I want to handle any homework questions you guys have. That's one thing. Second of all is probably have the test on Monday of next week because I want to be there Friday to handle any homework questions. Are we good with that? Does that make sense? Okay, so let's do this here. I wanted maybe today just to go ahead and review concepts from chapter 1. Friday we'll handle any homework questions from chapter 1, and then we'll take a test on Monday of next week. That's kind of like the goal in my mind here. Any issues with that you guys can foresee?
I have one question.
Uh-huh.
What homework is going to be due when, like, for chapter 1?
Sure. Let's see. I think 1.1, 1.2, it was already due the week before we went on break, correct?
Yeah, we haven't actually turned it in because there hasn't been a thing on Google Classroom.
Are you serious? Okay, let me, Isabel, let me correct that just to make sure it is all good to go. So I figured the old homework, 1.1, 1.2, 1.3 even, that's pretty old homework. I should just set it to be due here. I'm thinking maybe like tomorrow night, just for you to turn it in. Let me write this down as well. Just so I remember here. Let me get, I am pretty sure, let me actually just check. I am pretty sure I set up the, the Google Classroom. Let me check just the Algebra 2 piece right here. Grades, exam 1.1, and no, it is not there. Okay, thank you, Isabel, so much. Okay, so let's do this here. Homework 1.1, 1.2, 1.3.
Wait, you assigned 1.3. I don't think you ever assigned 1.3, so we didn't.
Yeah, I
have
don't think we have the homework for that.
Oh, okay. Well, can't turn it in if it's not assigned. Okay, so let's do this here. I'm going to send 1.3, 1.4, 1.5 homework for you guys today after I finish my next class here. I'm going to make 1.1, 1.2 due just tomorrow night, just so it's in there and I can start grading it. Okay, are we good there?
Yeah.
Okay, sounds good. I wrote it down, so finally I can hopefully do that. Okay, so let's turn around. I just want to review real quick here. Some of these will be easy problems, and I'm going to go to get some challenging ones here of chapter 1. So this is 1.1 through 1.5 review. I'll pick on you guys as well, just to sort of see how we're getting it. And we go from there, all right? So let me get off video. And let me redo my... Okay, I still see you guys on that screen. That's cool. And you guys should see a PowerPoint screen in front of you. Is that right?
Yeah.
Okay, let me get the... All right, let me just resetting here the screens here. Does this sound like looks like a deja vu moment from what, September? Is that right? When we're all in Zoom here in the beginning of the year. Okay, let's jam with it here. So I'm gonna go, this is a review of 1.1 all the way through 1.5. And good review just to sort of test yourself to make sure you guys are getting it. And at the same time, seeing if where your hangups are, where the issues are coming up for you here. So let's start back to 1.1. I'm gonna maybe assign the problem, and then we're gonna go through it here between the eight of you guys in the class here. Thinking what, maybe 16, 18 problems ish, somewhere in that range. So then you kind of see where you guys are doing good. So I'm going to call it chapter 1 stuff. There it is, chapter 1 stuff. Let's go ahead. Interview number 1, the easy stuff. Graph. And I figure I would throw in the problems from the textbook, but just make them just a little bit more difficult. That's all. Cool. So can you graph for me 11/3, 7/2 on a rectangular coordinate system? Can you graph for me this guy here? And we'll kind of go through the class as a whole. So I'm thinking maybe, let's see, we start from the right side of the class. We'll go to the left here. So I'll pick on you guys here. So Stella, you get number 1. Isabel, you get number 2. And since I'm not in the classroom itself, obviously, you just have to tell me what you did to get those numbers here, and then we'll work our way through. All right, so I'll write down the problem, give you guys maybe like 30 seconds or so to try it. Maybe a little longer for certain problems here. We'll go for it. So boom. And then if you have difficulty, you could say pass. If you need some help, Can help you through it as well here. So Stella, all yours. So graphing 11/3, comma 7/2. This is one of those bad ones to graph because they're improper fractions. So we need to figure out where in the world are we at. How do we do that? That's right. And you guys also have to speak up because I can't hear you. The mic is all the way up to the front of the room.
Is it possible for me to get some help?
Sure, sure. So perfect. And I threw in, this is a fun one. I threw this in here. Improper fractions, in our minds, we can't compute exactly where improper fractions are. So we have to convert them to something called mixed numbers. So 3 goes into 11 how many times? It goes in 3 times. That'll be 9. So that's 3 2/3 technically, right? So that's 11/3, but really 3 3/3. So now we have a reference easily. Now we have a reference where we're at on the number line. Stella, can you do the same thing for 7/2? What 7/2 is a mixed number? Or we could just divide it out, right? How many times does 2 go to 7? 3, perfect. Yep, 3 with 1 left over out of 2. Okay, so that's the one we're graphing. So if you're going to graph it here, it's going to be 1, 2, 3, 4, right? Because we need to go 3 2/3. Then we're going to go 3.5 high. 1, 2, 3, 4. Ooh, you know what? Let me transition to my red dot. So 1, 2, 3, 3 2/3 here. And then we're going to go 1, 2, 3.5 up. So it should be about right there. Should be actually between 2 grid lines, okay? So there it is, 11/3 and 7/2. Okay, a toughie one. Supposed to be a toughie. Through them here. I'd have show of hands here. Number 1. Never mind. I won't do that. I'll do it for a little bit later. Isabel. Isabel, all yours. Number 2. Tell me, how did you do it?
I just put in 2 different numbers for X, and then got Y from them, and then plotted both those points and then drew lines with them. I used 1 and 2 because, you know, easy. And the coordinates I got, hold on. I got, wait, 1, comma, negative 2 and 1/6. And then 2, comma, negative 2 and 2/6.
Okay. You used 1 and 2, yeah? 1 and 2?
Yeah. And then I got a line.
Awesome. Okay. Let's do this here. Perfect. Okay, Isabel did it. That's a perfect way to do it. This is called the table method. I would probably have chosen maybe 0, because 0 is such an easier number to plug in. And if you do plug in 0, notice that negative 1/6 goes away. So negative 2 would have been the point there. But you did everything fine. That's perfect if you did it that way here. The only thing is when you start plugging in ones, you got yourself a fraction, and now you got to deal with a fraction here. So you got negative 1/6 minus 2. And you talk to me. How did you undo this one? Negative 1/6 minus 2.
Well, since they're both negative, I kind of just added them together and then put a negative sign in front of them again.
That's perfect. Technically, it works because of this right here. And negative 1/6, negative 2 makes negative 2 and 1/6. Okay, so there's your 2 points. If you wanted them, you could have done it, and you're done. Okay, let me show you the easier way, you guys, to do it. So table method, you can always use it. It always works. It may be a slow method, but do you guys remember y is equal to mx plus b? That was like before vacation. All right. And so with this one, you're going to start all the way down at negative 2 along the y-axis, which is all the way down here. We're good. Hey, look at that. It's the same answer that we have over here from plugging into 0. All right. Isabel, you tell me here, because the -1 over here, where do we move?
To the, well, down, I guess. Down
Yep.
to the,
Perfect. We're going to move down 1. And then because the 6, we're going to move it to the right. So down 1, 1, 2, 3, 4, 5, 6 should have been, next dot should be like right there. All right. The reason why this is useful, first of all, is you don't need to do any more computational work. Second is you don't have to deal with fractions per se, because the fraction is really just a movement anyways. So you guys talk to me. And Isabel, let's see, is your line similar to this line, like this?
yes.
Perfect, yep. All right. Anybody else found an easier way than this to do it? Let's do another one like that. Let's go with number 3. Let me set up another one here. Thank you, guys. Thank you, Stella. Thank you, Isabel. Number 3. How about graph for me? This one, Landon. Y is equal to -2/5 x plus 3. I go with that one. And Dylan, of course, I'm going to change it up on you. 3x minus 2y is equal to I'm going to go 6 for now. That's fine. Yeah. So this is 1.1. This is the graph. This is actually technically 1.2 right here now. The graphing section. All right, give you guys a minute. Try it yourself here as a class. Try it, and then we'll do it together. All right, Landon, all yours. Let me just change my pin color, and you tell me what did you do and how did you do it?
So I started by going to +3 on the y-axis. And then from there, I went down -2 and 5 in the positive direction on the x.
Perfect. Yep, that is perfect. So 3, start off with 3, go down 2 along the y, and then 1, 2, 3, 4, 5. About right there, is that right?
Yep.
Sweet. And connecting a line. Don't forget to put arrows at the ends, and done. Okay. Everybody, are we okay with that? Just because it's so easy, notice you don't have to tabulate anything. We're just done. Good job, Landon. All right, Dylan, all yours, sir. How should we do number 4? Or can we make number 4 look closer to like number 3 if we wanted to? All yours. What did you do?
I started off by putting it in slope-intercept form, and I did that by adding 2y to both sides, and then subtracting 6 from both sides. And then there I divided both sides by 2, so I ended up with y equals 3 over 2x minus 3, which gave me the coordinate points 0x, or 0, -3, 1.5, -1.5, and 3, and -3.
Whoa, okay. Let me slow all that down. That's awesome. You said it all in like a single sentence. That's cool. So let's go with it here. So first things first is we're going to make it look like this one. So we're going to make it so that the y value is set equal to. And so subtracting 3x from both sides. Da, 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 da. -2y is equal to -3x plus 6. Is that, Dylan, am I headed in the right direction?
Yeah, I just did it. I added 2y instead of subtracting 3x, but I don't.
Good. So added the y and then subtracted the 6. Same difference here. Divide through by -2 here. That's what I'm going to do here. Right there. And that's gone. I'm left with y is equal to The negatives cancel here, just left with 3 halves. And -2 goes into +6 minus 3 times. So bam, there it is. Notice this little steps, right? You subtract the x, or take the x terms out to the other side, divide by whatever's multiplying y. And then I think we're ready for some graphing here. All right, Dylan, you said you went down to a -3 here to start off. Because of this guy. We went up 3, 1, 2, 3, and over 2, because this guy, and we are good to go. Is that what your graph looks like?
Yeah.
Okay. That is perfect. That is the way properly we do it. And we go from there. Real quick, I just want to show you something. Notice that in number 3, y is already equal to. And so we start off with this process right away, right? Notice we do have some computational work to be done here, right? And so let me go off to the side real quickly here. Another way to do this, especially since you have the x and the y on one side and then you have the constant on the other. This is called the intercept method. What we do is we do this right here. Oh. In our minds, what we do is we say this. If I were to plug a 0 in for the x, this guy here, if I did that, this whole thing goes away, right? And so question becomes, what's y going to be equal to? -2 times what gives you 6? -3, perfect. Yeah, -3. Notice, and then what happens on the other side? You just kind of do this. You kind of do this in your mind as well. If 0, if this guy goes away, 3 times what gives you 6?
2.
So you have your little coordinates already: 0, -3, and 2, 0. In fact, if you think about it, look at this. Those are the same exact coordinates we got here. Here's your 0, -3. Here's your 2, 0. Are we good? So which way do you do it? It doesn't matter. But if you have the x and y both on the same side, you kind of have the option of doing it either this way or this way for that. Okay, boom, boom, boom. Annette and Charlie. So Dylan and Landon, thank you so much. That was perfect. Annette and Charlie are up next. Let's go. Well, 5 and 6. Let's see what I come up with here. Didn't we have I think we had a midpoint formula. You guys remember midpoint formula? Let me go through my book in 1.1. I have one problem here already, but I think it was a different problem that we set up here when we did them. Yeah, I thought it was a distance formula in 1.1 and midpoint formula. Distance. Find me the distance from 5, 6 to -2, 7. And then find me the midpoint of -5, -3, and 9, +3. So Annette, you get number 5, Charlie, you get number 6. So this is the distance formula, the midpoint formula. And of course, I'm throwing negatives in there because that's what makes it a little more difficult. Okay, so class, try it as a whole. Give you like up to a minute on this one. All right, I'm gonna just begin a little bit here. So Annette, on this one, the distance formula, I think, was the square root of x2 minus x1 squared plus y2 minus y1 squared, I believe. Is that right? Tell me if you agree or disagree.
Yeah.
Cool. Okay. So then you tell me, what did you plug into here?
I did b equals the square root of -2 minus 5 squared plus 7 minus 6 squared.
I'd go with that. That's perfect. So kind of careful, especially when you're subtracting the negatives and stuff. And so in this case, -2 minus 5 will give you a -7 squared. And 7 minus 6 would just be a 1 squared. Perfecto. All right, tell me the rest here.
Oh, that would equal 14 plus 1. Then add that and then we just
Ooh, on this one, because you're not multiplying, you're squaring it. So it's -7 times -7.
oh. Is that 41?
49.
49.
49. Yeah, 49. And 1 squared is just going to be 1. So we got ourselves a square root of 50. The only problem is we do have to simplify this. Put it in simplest form as possible here. So can you simplify root 50?
If do 5 root 2.
Plus or minus 2.
Okay, I'm going to go with that here. So 50 is really 25 times 2. There's your perfect square of 5s. They get to go out. So final answer, 5 root 2. And it will still be a positive. We don't do plus or minus. We only do that when we're solving an equation. That's the only time we do that. Okay, Annette, are we good there with that one?
Yep.
Perfect. Charlie, all yours for this one?
I couldn't remember what the midpoint formula was.
No problem. X1 plus X2 divided by 2. Y2 divided by 2. I should have gave you guys the formula in the beginning. That was me. Okay, that's 1.1, 1.2. Here. All right, I'm going to start it here. Charlie, tell me, what did you plug in for?
So -3 plus 3.
Oh, okay.
X1.
That's going to go for the y values, right? Because those are the y values.
Oh, yeah.
Now for the x values,
-5 and 9.
perfect. Yeah, so it's just adding them up, divide by 2. So that would be -9. That's going to be a 4 divided by 2. That's going to be a 0 divided by 2. And any which rate, how about 2 comma 0? Will that work? Talk to me, Charlie, if you agree. Or no?
Yeah, I agree.
Okay. And then sometimes what you can do, you can actually even graph it, and it'll kind of, you're not trying to get an exact value from the graph, but you're trying to see if pinpoint if that makes sense. If -5 here, and -3 is down here. There's your -5, -3. And this is 9. 9 is going to be all the way here. 3. Does it look like it's probably going to hit? Yeah, it looks like 2, 0 might be like the middle point right there. Yeah, so just a quick graph. Okay, Annette, Charlie, good job. Awesome. Let's jump to Abe and Camille. Abe, do you have your calculator with you?
Yes, but it's broken.
Oh, that does not help. Okay, so let's go on to 1.2 then. So let's switch it up here. This was 6. This is going to be 7. Find center and radius of a circle. Let's see. Okay. All right, number 7 is like too easy. So I'm going to go like this. I'm going to go with, I'll do number 7. Number 8, write the standard form of a circle. And let's do the difficult one here first. Circle 4. Okay, let's do easy one first here. Camille or Abe? Camille, actually, Abe, I'm going to bug you. I'm going to give you the difficult one. I'll give Camille a slightly easier one here. Circle 4. Center is at -7, -4, and radius. Number 9. -1. Okay, so let's do this here. 7, 8, and 9. I changed it up. Number 7 is like it's way too easy. So let me do that. Also give you the formula. And then number 8, that's Camille, that's yours. And number 9, that is going to be Abe's.
Can you read off the problem? I'm having trouble reading it. Sorry.
Sure, yeah. So for number 7, find the center and radius of a circle. It's x squared plus parentheses y minus 1 squared equals 25. Number 8, find the standard form of a circle for center being -7, -4, and radius is 7. Find the standard form of a circle for endpoints. So the endpoints here are 0, 0, and 6, 8. That means it's not the center and the radius. It's actually one side of the circle hits 0, 0. The other side of the circle hits 6, 8. All right, so let me give you the formula. Sorry, class, are we good there? Did everybody at least got the understanding of it? Formula, here it is. Formula is x minus h squared plus y minus k squared is equal to r squared. Center is hk, but notice the minus signs are actually part of the formula, right? Radius r. Okay, so the formula is x minus h squared, y minus k squared is equal to r squared, where the center is hk, the radius is r. All right, let's go with it here. So I get number 7. This one, find the center and radius of the circle. Notice that there's just x squared by itself. There's no nothing beyond that here. So if you want to just kind of rewrite it just to sort of tell the story. Here's the way you kind of rewrite it to put into that form. So notice that x by itself, the x squared, is really technically x minus 0 being squared. So for me, for my answer, the center is going to be at 0, 1. Radius is equal to 5. Okay, are we good with that? Agreed, disagreed? Boom. Camille, to bug you here, can you give me the answer for 8?
No, because I don't know what's going on.
Okay,
I don't
that
remember this.
think it's a good last thing.
She said she doesn't remember this.
Okay, gotcha. This is all the way from 1.2, so let's do it together. No problem. So according to the formula up here, upper right-hand corner here, you got x minus h squared, y minus k squared is equal to r squared. We're just putting into that little form right there. The x and the y, those are variables, so those are going to stay as is. So we're just plugging in this guy for h. This guy goes in for the k. And then this guy goes in for the r value.
And then how would I find mine? 'Cause I don't have a radius. So,
Abe, is that you?
yes.
That's why I gave you the tricky one. And so center is an x. So Camille, it's going to be x minus a negative 7, right? Because you're plugging in this little guy here. So what we do is we do that. Does that make sense to you? Hey, Camille, talk to me here. See if this, tell me if this makes sense.
I think. I don't know.
No problem. This is where we start working things in. So let me show you the long way as we're putting this in. So the formula says x minus h, right? So as you put this in, it's going to be x minus a negative 7. That's kind of what we put in. But because it's a negative, subtracting a negative, same thing as adding a positive, those just turn into pluses. All right, can you do the next one? Okay, no problem. We'll do it here. So the next one is going to be y minus k. In this case, it's going to be y, let's see, subtract a negative 4 this time as we're putting it in. We're going to square it, but then subtracting a negative, same thing here. Subtracting a negative, same thing as just adding a positive. Then afterwards, the formula says equal to. Camille, is that making sense more? You talk to me.
Yeah.
Okay. And then the last one, it's not just r at the end, it's actually r squared. You talk to me. What's going to happen with that 7?
It's going to become 49.
Perfect. Yep. There it is. There it is. There's your, you just created the equation of a circle. And again, there's so many things in our world. Just think of, you guys talk to me here. Think of the times that you guys see a circle in your life, in your day. I'm thinking like the clock, because I see a clock in the back of the room over there. Technically, as they were manufacturing that, they had to figure out what is going to be the area. They have to figure out the equation of that circle before they put it into the mold over there. Tires, I'm thinking tires of a car, wheels on a car, steering wheel. Right, we have so many things that sort of pop at us as a circle form. Rockets, you know, if you look at them, not sideways, but down. Those are all circles, right? Those technically just a cylinder, right? You extend a cylinder, right? Take a circle, right? So in life, we do a lot of stuff with circles. Okay, Camille, are we good with 8?
Yeah.
Okay, Abe, now I'm all yours, man. Talk. How should we do this? We got to figure out the standard equation of a circle based upon just it.
I have no idea what to do.
Okay, no problem. So let's draw it out, class. Let's draw it out. So endpoints just mean that they're touching the circles. So in this case, I know one endpoint is 0, 0. And then the other endpoint is 6, 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Whoa, all the way up here. So here's the other endpoint. So our circle kind of goes like this. Whoa, sorry, hold on. Let me draw that better. That did not look like a nice circle. That looks even worse.
But for the radius, could I just use the distance formula and then divide it by 2?
That's what I'm thinking too. Yeah, absolutely. So this one kind of has a few more details in here. A few things. Abe, real quickly here. Aren't we trying to get the center of the circle?
Oh, so I can just do the midpoint?
There you go. So classes, that makes sense. That's going to be right there. That's going to be the. So now the question is, what's the middle of 0, 0 and 6, 8?
3, 4.
3, 4 is perfect. 3, 4 is the middle. That's okay. I got that piece there. So now the question is, how do I get the radius?
Now do I have to do the distance formula?
Now I'm gonna have to use distance formula. Yep. So let me jump to the next slide, but I'll do the same problem here. So boom, jump to this real quickly here. So now we're trying to figure out this. We're trying to figure out I got 0, 0 here. I got a 3, 4 here. I got a 6, 8 over here. So I think it's easier to figure out the distance here because you got zeros involved. So the distance formula from 0, 0 to 3, 4. That's kind of what you're looking at.
Can I also just use the original point and then divide it by 2 in the end?
Use the original point to do what?
And then divide it by 2 in the end to get the radius?
Yes.
If you already got the distance from here to here, yeah. Did you get the distance from there to there?
Yeah, well, I got the distance from 0, 0 to 6, 8, and then I just divided it by 2.
Oh yeah, that would perfect. That would do it. And what is that distance that you got?
I got 5.
5 is good. Yep. In fact, do you guys remember from geometry days? Do you guys remember if you have a length of 3, another length of 4 on a right triangle?
Oh, yeah.
There's our 5 right there. And if you did it the long way, then you would have got 3 minus 0 squared plus 4 minus 0 squared would have been 3 squared plus 4 squared. Just doing them real quickly here. 9 plus 16 gets you square root of 25, which is just 5. All right, Abe, all yours. The final answer. Abe, all yours. Putting it all together here. What do you got here? Give me the equation.
So, let's see. Wait, so what am I putting it into? Like, what standard form?
This guy right here.
Oh, that'd be x minus 8. Okay. That's x minus 3 squared plus y minus 4 squared equals 25.
That is perfect. There it is. We got the standard form of the equation. Okay, that was 1.2 2, 1.3 had to deal with slope. So let's do that one just as a class here. We're going to go, let's see. Oh, we had to go backwards on them. Okay, so 2 more problems, guys, as a class. Let me go back to my black pen here. We are on problem number 9, 10. So 10. Problem number 10. Can you guys do this one for me? You can write the equation of a line. Let's start off easy here, and then work our way to more difficult ones here. So slope is -2 and passes through 3, 4. And then we'll go on to okay, those 2 problems here. I think we'll have just enough time to do those. The formula that we need to use is the point slope form. So you guys remember this one from before vacation. All right, did the garbage truck finally pass by? Yay, all right. Garbage truck is still steady. Okay, number 10. This is called the point slope form. And we need a point and we need a slope. As long as we have those 2, we get ourselves what we need to set this up. So in this case, slope is -2. Awesome. I'm going to plug in that little -2 right into that little m value. The 3 goes into the y1, and the 4 goes into x1. So it's written as y minus 4 equal to -2 x minus 3. Perfecto. So this is in order to get equations off the line. So you're looking at a graph, you're like, I want the equation of that line. All right, and normally what we do is then we just solve for the y value. So always distribute the slope. Move the constant over, running out of room here. So how about y is equal to -2x plus 10? Tell me agree or disagree.
Agree.
Awesome. The other side is what happens if you just have 2 points that passes through. That's all you see. As you're looking at a graph, like this line passes through -4, -4, also passes through -8, -6. I still want to equation this line. The equation I'm going to use is that right there. Am I missing something? I think I'm missing something, guys. Is that right? I'm missing my slope. The previous problem, I was able just to plug in the -2. So because I can't plug in my slope, I'm going to have to use the slope formula. Get the y2 minus y1, x2 minus x1, I believe. All right, with time running out, let's go for it. So I think it's -6, subtracting. And remember how I said it's a lot easier just to plug in. We'll put in little parentheses here. The -6 minus -4, -8 minus -4. Now let's see what happens here. In fact, you guys calculate it for me. Tell me what you guys get for slope.
2.
2, okay. I'll go with that here. You got a -2 on top. I got -4 on the bottom. I got myself a 1/2. Is that true? You guys agree or disagree?
Agreed.
Agreed, okay.
Yeah.
All right, we've got about exactly a minute left here. Let's put this together here. So then we've got to choose a point. It doesn't matter which one you choose because both these guys are on the line. So it doesn't matter. I'm going to choose -8, -6. So as I plug this in, careful, these guys are now negative terms. So it's going to be y minus a -6, which really just changes into a +6. My 1/2 as my slope comes in, and x minus a -8 is just +8. All right, can you guys finish it off? Go. And 30 seconds left.
Is it y equals 1/2 x? Y.
-2.
Minus 2. No. Just 2. Is that a 4 or 2? That's a 4. -2.
Okay, I agree. Bam, perfecto. And you guys are done. All right, thank you guys so much. I hope to see you guys on Friday.
Thank you.
Have a good
I'll try the back if you want.
Okay, okay.
All right, let's see. Landon, the only thing is, could you ask Mrs. Rain to come in sometime to set up the calculus class?
Turn on what?
Can you ask Mrs. Rain to come in to set up the calculus class Zoom meeting?
No problem.
Okay, cool. Thank you.
Get well soon.
Thank you.
Yeah.
Like, it was, but,
At least it's on paper.
yeah, okay. Only I can do every single one because I didn't know which one was that in.
Isabel, thank you so much for doing the chairs.
No problem. Oh. Thank you.
All right.
Are you ready, Art? Just gonna plug in the next class.
Okay, I am going to stop now.